Alright, this video is going to cover situational problems. These problems typically require a little bit more work and a little more thought than your pure math algebra questions. As you can see, there are 6 topics that will be covered in this video. Feel free to pause and skip around as needed. The first type of question we're going to talk about are test problems. These problems are pretty common when you look at practice tests. These show up pretty much on every practice test. So what we want to look at today are 2 ways of doing this problem. The first way is work backward from the solutions. So you got 4 solutions here, and then the K solution is the student cannot have an average of 80. And number 2 is work forward, just simply like figure the problem out. So the first way to solve this question is to work backward. Pick an answer choice and plug it in for the average. So we got 4 tests given. We want to find out what we need on the 5th test to average 80. So the 5 tests they gave me, or the 4 tests they gave me, were 65, 73, 81, and 82. So altogether, those tests add to 301. So you got to figure out which one of these 4 choices, if you add it to that and then divide by 5, will give you the average of 80. So I'm going to start with 99. And if I add 99 to 301 and divide it by 5, I get 400 divided by 5, which gives me my average of 80. So that right there tells me the answer to the problem. The other method that we can approach this problem with is by just using algebra. And if you know how to do this problem, you don't have to work backward, because sometimes that takes a little bit of unnecessary time. So to work forward, you basically just say 65 plus 73 plus 81 plus 82 plus x divided by 5 equals 80, and you solve that equation. So when you do this, you multiply both sides by 5. And this gives me, this is going to cancel out this 5. I'm going to get 301 plus x equals 400. Subtract 301, and you see you get x equals 99. So these are 2 ways with which you can get 99. The other thing some students have said is just look at the question, right? His scores, or whoever this is, a student, his or her scores are 65, 73, 81, and 82. So they're all below. 2 of them are below 80, and 2 of them are just a little bit above 80. So to average an 80, you're going to need to do better than 75, 76, or 78, absolutely. So it's either 99 or nothing. So I guess working backwards isn't, if you have a little bit of a clue, working backwards from the answers, you probably would start with 99. So this next problem we're going to look at is a probability problem, and probability questions show up all over the ACT. You got to remember a very simple formula for probability. Probability is the number of favorable outcomes over the total possible outcomes. So in this particular problem, you're working with marbles. You have 8 red, 6 blue, and 6 white, and the question asks you what the probability is that the marble will not be white. So the favorable outcome here is that the marble is not white. Okay, so the first thing I got to determine is how many total outcomes, and that's just simply adding 8, 6, and 6, which gives me 20 total outcomes. If I look at not white outcomes, you have 8 red and 6 blue, so not white outcomes gives me 14. So when you're looking at this probability, you got favorable outcomes at 14, total outcomes at 20. So the probability that a marble is not white when it's chosen is 14 out of 20. And if you look at the answer, you're like, I don't see 14 out of 20. That's because you just simply have to reduce, take a 2 out of top, 2 out of bottom, and the answer is 7 out of 10. So that's a simple probability question. They can be more complicated, but the process for finding probability is nothing more difficult than simply taking the favorables over the total. The next type of question we're going to look at are distance equals rate times time problems. You see these problems typically in your physics classes, and you got to watch out for word problems that talk about a situation in which someone is traveling, like somebody traveled a certain distance in a certain amount of time, or they give you different things based upon a travel situation or a trip. And this problem says Kayla drove 200 miles in 5 hours. It says by driving an average of 10 miles an hour faster, Kayla could have saved how many hours? So this one just requires you to think a little bit. You guys have all traveled on a trip. Just think about it like if you go 200 miles in 5 hours, how fast were you going? So to figure that out, you could use the formula if you want. So 200 miles is your distance. You want to find out how fast you were going at first because it took 5 hours. So dividing by 5, you see that your rate is going to be 200 divided by 5, which ends up being 40 miles per hour. So that's your rate. Okay, cool. So it says, what if you go 10 miles an hour faster? How many hours of driving would you have saved? Not how many hours of driving would it have taken you. It says how many hours of driving would you have saved. So 10 miles an hour faster than 40 is 50. So if I'm going 50, how many hours is it going to take me to go 200 miles? So then I go back and I do another distance equals rate times time situation. So I'm still going the same 200 miles, but now my rate is 50. So the question is, how long is it going to take you? So if you divide 200 by 50 in this case, the time now, not your rate now, it's going to be the time is going to be 4 hours. So the initial trip took me 5 hours. If I go 10 miles an hour faster, it's going to take me 4 hours. So the total amount of time saved, if I go from 5 to 4, you saved an hour. So it's just a thought question too. It's a distance equals rate times time. Just look out for situation problems that involve distance and rate and time. And this one's a good question because it asks you two questions. So number one, you had to find out how fast you went for the initial trip, and number two, you had to find out how long it would take you to travel that 200 miles going 50 or going 10 miles an hour faster than the initial trip speed. So. All right, the next problem that pops up a lot are combination problems. When a problem asks you for the number of possible combinations, it's usually as simple as multiplying together. And these problems show up at least once per ACT, so watch out for these questions. These should be slam dunk questions if you just recognize it. So looking at this one, it says Marco and Anita own a sandwich shop. They offer 3 kinds of bread, 5 kinds of meat, and 3 kinds of cheese. Each type of sandwich has a combination of exactly 3 ingredients, 1 bread, 1 meat, and 1 cheese. How many types of sandwich are possible? So you have simply just multiply. You got 3 kinds of bread, 5 kinds of meat, and 3 kinds of cheese. So looking at these problems, I mean, it's just good to review this. 3 times 5 times 3, there would be 45 possible sandwiches. So your answer to this one is D, 45. So watch out for combination problems when I ask you the possible number of combinations given a few different types of things. Right, the next thing we're going to talk about are setting up proportions. These problems are probably the most important thing we're going to talk about on this video. A lot of problems on the ACT can be solved by setting up a proportion, and this is what you do when you've determined that a relation of some sort exists. So for this particular problem I'm looking at, it says the weight of a circular rod of a certain type is proportional to its length. And there's a key term there. Okay, if you see that word, you know a proportion is probably going to be set up in this problem. There's probably one way in which you can solve this problem. So once again, just kind of tips here, look for the word proportional. Like this problem, you see it right here. Okay, this won't always be there, but when you see it, setting a proportion is usually, and I say that with the capital U, capital S, and so on, because it's not always going to be the way in which you solve problems that say the word proportion. So, looking at this problem though, a proportion will be used to solve this one. It says the weight of a circular rod of a certain type is proportional to its length. A 15-foot rod of this type weighs 35 pounds. What is the weight in pounds of a 21-foot circular rod? So, to see this one, setting up a proportion, you say 15 feet is to 35 pounds as, and you say it like this in my head. I mean, when I remember setting up proportions to taking the ACT, you literally say 15 feet is to 35 as 21 feet is to X pounds. So now you're looking at this particular problem, and it's simply just a proportion. You got two ratios equal to each other. How you solve this is by cross multiplying. So first thing, I take 21 times 35. And that gives me 735. 15 times x gives me 15x. Divide both sides by 15. And I get x to be 49 pounds. And that should make sense, right? It's a longer rod. A 15-foot rod weighs 35. 21 foot, it's got to definitely weigh more. And in this case, 49. So you see that problem is easily set up by solving a proportion. All right, there's another example here that I wanted to talk about because, again, you see a relation exists. And again, this one doesn't say the word proportion, so this one you might have to just think about it. I see that there's a relation in which there's one thing happening that causes this to happen. If this other thing happens, what do you know about, the second part? So, I mean, looking at this particular problem, you got a refinery, 100,000 tons of sand are required to produce each 60,000 barrels of Atari material. So that first relation, you got 100,000 tons of sand, makes 60,000 barrels of tarry material. How many tons of sand are required to produce 3,000 barrels? So you got 100,000 tons of sand, makes 60,000 barrels of tarry material, right? And the question asks, how many barrels of sand? So I say this number of barrels of sand to that number, that many tons of sand to barrels of tarry material, and then I got how many tons of sand to 3,000 barrels of tarry material. So this is the setup, and it's a proportion. It's a relation in which you have one thing which leads to this, which 100,000 leads to 60,000. How many leads to 3,000? So when I do this particular question, you cross multiply, get 60,000 x times 3,000 times 100,000. So that's 3, 1, 2, 3, 1, 2, 3, 4, 5. And here's where you pull out your calculator and divide both sides by 60,000. And you'll get your answer. My answer ends up being x equals 5,000. So 5,000 tons of sand will produce 3,000 barrels of tarry material. And another way to think about this problem is to just think about the fact that 100,000 to 60,000 is like a 10 to 6 or a 5 to 3 ratio. If you just think about that, when you're like, well, if it's a 5 to 3 ratio and I make 3,000 barrels of tarry material, then that would mean 5,000 barrels of sand. So, I mean, there's quicker ways of doing this problem, but if you just recognize the proportion, set up a proportion and solve. The last type of question we're going to talk about are word problems that tell you what to do. Okay, capital letters. So, when you see this, read carefully because sometimes what to do is explained in the problem. Okay, these problems are sometimes, it's kind of difficult because you have to read through it, and it's more of like a reading comprehension problem than it is a math problem, because what this question here, it's got 7 or 8 lines of words, but the process in which you find the answer is nothing more than elementary. I mean, it's just dividing two numbers and coming up with a percent, something that you probably learned in junior high. But the actual problem itself is much more advanced than a junior high problem. But looking at this problem tells you what to do, believe it or not. So let's read through it carefully. And again, that's where you see a word problem. Just read carefully, because typically word problems and the situational problems, you're going to know what to do because the problem sometimes will tell you what to do, like this one will. So looking at this one, it says the oxygen saturation level of a river is found by dividing the amount of dissolved oxygen. So I'm going to write this down. So I'm going to divide the amount of dissolved oxygen by the oxygen the river water currently has per liter, and a bunch of extra words in there, by the dissolved oxygen capacity. So the dissolved oxygen divided by the dissolved oxygen capacity. So what you see here is you got the dissolved oxygen that the river has divided by the dissolved oxygen capacity is how you find the oxygen saturation level. Okay, so this problem told you exactly what to do in the first few lines. It's very weird and complex and all convoluted with all those extra words, but it's literally telling you what to do if you just take your time and read carefully. So now the next part basically is going to give you the numbers in which you got to solve with. So it says if the river currently has 7.3 milligrams of dissolved oxygen per liter, so if I have 7.3 milligrams of dissolved oxygen per liter, and the dissolved oxygen capacity is 9.8 milligrams per liter, what is the oxygen saturation level to the nearest percent? So they told you what to do. The oxygen saturation is given by taking the dissolved oxygen divided by the dissolved oxygen capacity. All right, the dissolved oxygen is currently 7.3, the capacity is 9.8. So this seems all complicated, but really this problem told you what to do. And watch out for problems that do this, okay? So when you see this many lines, I'm always going to say this, more often than not, okay? I would say 80% of the time, these problems are not difficult. Okay, the difficulty is going to be in sorting through the information. The math involved in these problems is not going to be very high level like this one. I don't have to do anything more than divide 7.3 by 9.8, which gives me 0.745. So, or 0.7448 if you want to be more technical. Let's just write that because that's going to be the answer here. So 0.7448. So now it's like, what to the nearest percent? Well, if I round this thing to the nearest percent, it would just be 74%. So the oxygen saturation level is at 74%. And again, this problem, it's very convoluted. It's a lot of words, but really it told you what to do. So watch out for problems that are going to tell you what to do.